For decades, the idea of life on Mars has captivated scientists and the public alike. From historical observations to ongoing missions, let's explore the mystery of potential Martian life. Is there a chance, however small, that life exists on our red neighbor? Could there be Martian microbes hidden beneath the surface, or fossilized evidence of creatures long gone? Join me as we delve into the tantalizing possibility of life beyond Earth. Our fascination with Martian life began long before we sent probes and rovers to the Red Planet. In the late 19th century, astronomer Percival Lowell peered through his telescope and imagined he saw canals crisscrossing the Martian surface. He theorized these were feats of engineering built by a civilization struggling to survive in a drying world. While Lowell's canals were eventually debunked as optical illusions, they ignited the public imagination. Science fiction writers spun tales of advanced Martians, and the idea of a neighboring world teeming with life took root in our collective consciousness. Then, in 1976, came the enigmatic face on Mars. Viking 1, one of NASA's early Mars orbiters, captured an image of a mesa in the Cydonia region that, under the right lighting conditions, looked strikingly like a human face. Later, higher-resolution images from missions like Mars Global Surveyor revealed the face to be a natural formation, a trick of light and shadow. While we haven't found canals or carved faces, Mars continues to offer intriguing hints that life might exist, or might once have existed, on its surface. One of the most compelling pieces of evidence comes in the form of methane gas. Methane is a molecule that can be produced by both geological and biological processes. On Earth, the vast majority of methane in our atmosphere is released by living organisms. NASA's Curiosity rover, trundling across the Martian surface since 2012, has detected fluctuating levels of methane in the Martian atmosphere. These fluctuations appear to be seasonal, with methane levels rising during the Martian summer and falling during the winter. This suggests an active source of methane on Mars, one that responds to changes in temperature and sunlight. Could this be a sign of microbial life hidden beneath the surface, releasing methane as a byproduct of their metabolism? Further fueling the possibility of life are detections of methane plumes by orbiting spacecraft like the European Space Agency's Mars Express. The surface of Mars, bombarded by radiation and scoured by dust storms, is a harsh and unforgiving place. If life exists on Mars today, it likely hides beneath the surface, where conditions are more stable and potentially more hospitable. That's why our robotic emissaries, the Mars rovers, have been tirelessly digging, drilling, and analyzing the Martian soil and rock, searching for any sign, past or present, that life might have gained a foothold on this alien world. One of the most exciting discoveries came in 2018 when the Curiosity rover unearthed organic molecules in ancient Martian rocks within Gale Crater. Organic molecules are the building blocks of life as we know it, containing carbon and other elements essential for life's processes. While these molecules don't definitively prove the existence of past life, they demonstrate that the ingredients for life were present on ancient Mars. Further evidence of Mars's wetter, potentially more habitable past comes from Curiosity's exploration of Gale Crater. The rover found compelling evidence that the crater was once a vast lake, with flowing rivers depositing sediments over eons. Currently, the Perseverance rover is busy exploring Jezero Crater, a site chosen because it too is thought to have once been a lake, complete with a river delta. Perhaps within the layered rocks of Jezero Crater, Perseverance will uncover fossilized microbes or chemical traces of ancient life, rewriting our understanding of life in the universe. Chapter 4. Life as we don't know it. Lessons from Earth's extremophiles. When we imagine life on other planets, it's easy to fall into the trap of thinking only of life as we know it here on Earth. But the universe is vast and varied, and life, if it exists elsewhere, may have taken forms we can scarcely imagine. Fortunately, we don't have to travel to other planets to find examples of life thriving in seemingly impossible conditions. Here on Earth, we have extremophiles. Extremophiles are organisms, mostly microorganisms, that have adapted to survive and thrive in conditions that would be lethal to most other life forms. We find them in the boiling hot springs of Yellowstone, the acidic pools of volcanic craters, the dry valleys of Antarctica, and even in the crushing depths of the Mariana Trench. These extremophiles teach us that life is incredibly resilient and adaptable. On Mars, where the surface is exposed to harsh radiation, the atmosphere is thin, and temperatures fluctuate wildly. Life, if it exists, would likely resemble Earth's extremophiles. Scientists theorize that Martian life, if present, might be found underground, where it's protected from radiation and where liquid water might exist in the form of aquifers or briny seeps. The Martian subsurface could be a haven for microbial life, drawing energy from chemical reactions rather than sunlight. Chapter 5: Unanswered Questions. The mysteries yet to be solved. While we haven't yet found definitive proof of life on Mars, the possibilities remain as vast and intriguing as the planet itself. Each mission, each discovery brings us closer to answering one of humanity's most profound questions. Are we alone in the universe? The search for Martian life is far from over. Future missions, equipped with even more sophisticated technology, will continue to probe the Martian mysteries. Could vast aquifers, hidden beneath the Martian surface, harbor entire ecosystems of microbial life? Could fossilized remains of past life be preserved in the Martian rock record, waiting to be discovered? Perhaps most tantalizingly, could life on Mars be based on a completely different biochemistry than life on Earth? Chapter 6: The Challenges of Exploration Protecting Mars and Ourselves. As we venture further into the cosmos, driven by our insatiable curiosity and our desire to understand our place in the universe, we face a profound responsibility to explore responsibly, to protect the environments we explore, and to ensure that we don't inadvertently contaminate other worlds with life from Earth. Mars, despite its harsh conditions, is a fragile world. Its thin atmosphere, lack of a global magnetic field, and extreme temperature swings make it vulnerable to contamination. If life exists on Mars, it could be easily disrupted or even wiped out by the introduction of Earth-based organisms. That's why planetary protection is paramount in all our Mars missions. Spacecraft are meticulously sterilized before launch to minimize the risk of carrying Earth microbes to Mars. Landing sites are carefully chosen to avoid areas where liquid water might exist near the surface, further reducing the chance of contamination. But planetary protection is not just about protecting Mars from Earth. It's also about protecting Earth from potential Martian life. Chapter 7: The Future of Mars Exploration, a New Era of Discovery. The quest to determine whether we are alone in the universe is one of humanity's most profound scientific and philosophical endeavors. And Mars, our closest planetary neighbor, stands as a beacon in this search, a world that might hold the key to unlocking this cosmic mystery. The future of Mars exploration is bright, with a host of ambitious missions planned by space agencies and private companies around the world. NASA and the European Space Agency are collaborating on sample return missions, aiming to bring Martian rocks and soil back to Earth for in-depth analysis. These samples, scrutinized by the most sophisticated laboratories on Earth, could provide definitive evidence of past or present Martian life. China, with its burgeoning space program, has its sights set on Mars as well. The Tianwen-1 mission, which successfully landed a rover on Mars in 2021, marks a significant step forward in China's interplanetary ambitions. Future Chinese missions could include sample return attempts and even human exploration. Private companies like SpaceX are also playing an increasingly important role in Mars exploration. The coming decades promise to be a golden age of Mars exploration, a time of unprecedented discovery that could fundamentally change our understanding of life in the universe. Are we alone? The idea of a creature or microbial life on Mars remains speculative but tantalizing. Each discovery, from hints of methane to evidence of ancient lakes, brings humanity closer to answering one of the greatest mysteries. Are we alone in the universe? Whether we find evidence of Martian microbes, fossilized remnants of ancient life, or perhaps something even more extraordinary, the journey itself is a testament to the power of human ingenuity and our unquenchable thirst for knowledge. The quest to solve the mystery of life on Mars is a journey that will captivate generations to come, pushing the boundaries of science and inspiring us to reach for the stars.